Hi, it's Mr. Anderson, and right now I'm actually playing Angry Birds. Let me get this down. Angry Birds is a video game where you get to launch Angry Birds at these pig-type characters. I like it for two reasons. Number one, it's addictive, but number two, it deals with physics, and a lot of my favorite games deal with physics. And so let's go to level 2. And so what I'm going to talk about today are vectors and scalars. And vectors and scalars are ways that we measure quantities in physics. And Angry Birds would be a really boring game if I just used scalars. Because if I just used scalars, I would input the speed of the bird, and then I would just let it go. And it'd be boring because I wouldn't be able to vary the direction. And so in Angry Birds, I can vary the direction, and I can try to skip this off of... Nice. I can try to skip it off and kill a number of these pigs at once. Now, I could play this for the whole 10 minutes, but that would probably be a waste of time. And so what I want to do is talk about scalars and vector quantities. Scalar and vector quantities, I wanted to start with them at the beginning of physics because sometimes we get to vectors and people get confused and don't understand where did they come from. And so we have quantities that we measure in science, especially in physics, and we give numbers and units to those, but they come in two different types, and those are scalar and vector. To kind of talk about the difference between the two, a scalar quantity is going to be a quantity where we just measure the magnitude. And so an example of a scalar quantity could be speed. So when you measure the speed of something, and I say, how fast does your car go? You might say that my car goes 109 miles per hour. Or if you're a physics teacher, you might say that my bike goes, I don't know, like 9.6 meters per second. And so this is going to be speed. And the reason it's a scalar quantity is it simply gives me a magnitude, how fast. How far, how big, how quick. All those things are scalar quantities. What's missing from a scalar quantity is direction. And so vector quantities are going to tell you not only the magnitude, but they're also going to tell you what direction that magnitude is in. So let me use a different color maybe. Example of a vector quantity would be velocity. And so in science, it's really important that we make this distinction between speed and velocity. Speed is just how fast something is going, but velocity is also going to contain the direction. In other words, I could say that my bike is going 9.08 meters per second west. Or I could say this pen is being thrown with an initial velocity of 2.8 meters per second up or in the positive. And so once we add direction to a quantity, now we have a vector. Now you might think to yourself, that's kind of nitpicky. Why do we care what direction that we're flowing in? And I have a demonstration that'll kind of show you the importance of that. But a good example would be acceleration. And so what is acceleration? Acceleration is simply change in velocity over time. And so acceleration is going to be the change in velocity over time. And so I could ask you a question like this. Let's say a car is driving down a road and it's going 23 meters per second and it stays at 23 meters per second. Is it accelerating? And you would say, no, of course it's not. Let's say it goes around a corner and during that movement around the corner it stays at 23 miles per hour. Well, what would happen to the scalar quantity of speed around a corner? It would still be 23 meters per second. And so if you're using scalar quantities, we'd have to say that it's not accelerating. But since velocity is a vector, if you're going 23 miles an hour and you go around a corner, are you accelerating? Yeah, because you're not changing the magnitude of your speed, but you're clearly changing the direction. And so a change in velocity is going to be acceleration. And so you are accelerating when you go around a corner. And so that'd be an example of why in physics, I'm not trying to be nitpicky, I'm just saying that you have to understand the difference between a scalar quantity, and then which is just magnitude, and a vector, which is magnitude and direction. And there's a review at the end of this video, and so I'll have you go through a bunch of these, and so we'll identify a number of them. But for now it's a huge thing. So there are lots of things that we can measure in physics. And so what I'm going to try to do, hopefully I can get this right, is go through and circle all the scalar quantities and then go back and circle all the vector quantities. And so if you're watching this video, a good thing to do would be to pause it right now, and then you go through and circle the ones that you think are scalar and then vector, and then we'll see if we match up at the end. Scalar quantities, remember, is simply going to be magnitude. And so the question I always ask myself when I'm doing this is, okay, does it have a direction? And so length is simply the length of a side of something, and so I would put that in the scalar perspective. This is kind of philosophical. Does time have a direction? I would say no. Acceleration, we already talked about that. That's changing in velocity. What about density? The density of something, that definitely is a scalar quantity. If I say the density of that is 12.8 grams per cubic centimeter north, that doesn't make sense at all. Where's some other scalar quantities? Temperature would be a scalar quantity. It's just how fast the molecules are moving, but it's not in one certain direction. Pressure would be another one that's scalar. It's not directional. It's not in one direction the pressure is. Remember, air pressure is the one that I always think of, is going to be in all directions, so we wouldn't say that. Let's say mass. The mass of something is going to be a scalar quantity as well, and so it doesn't change. Now weight, and we'll talk more about that later in the year, would actually be a vector quantity. Let's see if I'm missing any here. No, I think this would be good, so let's change color for a second. So displacement is how far you move from a location, and that's in a direction. So we call that a vector quantity. Acceleration I mentioned before. Force is going to be a vector, and we'll do these force diagrams, which are really fun, later in the year. Drag is something slowing you down. So if you're a car, it's what's slowing you down in the opposite direction of your movement. So the direction is important. Momentum is a product of velocity and the mass of an object, and lift we get from like an airplane wing. That would be a vector quantity because it's in a direction. And so these are all vector quantities, the ones that I circled in red, but there are way more that we're going to find out there. And scalar quantities, remember, it's simply just magnitude, or how big it is. And so as we go through physics, be thinking to yourself, is this a scalar quantity or vector? And if it's vector, my problem is a little bit harder, but like Angry Birds, it's more fun when you go the vector route. And so I hope that's helpful, and have a great day.